And next one, we are going to learn about the air and the atmosphere. So air in the atmosphere can occupy a space and it is having a weight. Whatever object which is having a weight and it can occupy a space, it can offer pressure. So this air can offer pressure. So that is what we are going to learn here. The first concept we are going to learn here, it is the atmospheric pressure. So what is this atmospheric pressure? So air is a combination of gases. These gases are present in the atmosphere, and this atmosphere is thicker when it is closer to the surface of the earth, because all because of gravity, the heavier particle uh, will be held close to the surface of the earth. Okay, so when it is having a heavy weight, thicker, high density, the high density gases will be closer to the surface of the earth. That is why the atmospheric pressure will be high when it is closer to the sea level, when it is closer to the surface. When we are going or when we are climbing altitude, so it varies, and the atmospheric pressure, it actually decreases. That is why when we are climbing the mountain, we feel hard for breathing. And in aeroplanes, they are maintaining the air pressure inside the fuselage for the comfortness of the passengers, because in that altitude the pressure will be very, very less. Okay, and now we can measure the pressure as force per unit area. Okay, this force is measured in kilogram weight, and this area is measured in centimeters cube. We already saw it with the activity 1 when we are calculating the weight, the pressure of the iron blocks. Okay, so the one atmospheric pressure, it is equal to 1 kg per square centimeter. Say for an example, we will take our head itself. Okay, let's consider our head surface area. Top surface area is 15 cross 15 centimeter. That means 225 square centimeter of area. Okay, 225 square centimeter of area means what will be the pressure experienced by that area? So atmospheric pressure will be 1 kg per square centimeter. So 1 into 225 square centimeter, 1 kg into 225 square centimeter, it will be equal to 225 kg. So if we are going to place 225 kg over our head will be crushed actually. But in reality, it is not getting crushed. Why it is not getting crushed? It is all because of the internal pressure. It is equalizing the atmospheric pressure. Okay, so the internal pressure inside our body, it is neutralizing the atmospheric pressure because we are living in that atmosphere. Okay, so we are not getting harmed by this atmospheric pressure. Next one, learning about the atmospheric pressure with an experiment done by Otto von Brick of Germany. Okay, he is making a metal sphere of around half a meter diameter, and he is evacuating the air inside it. That is making the sphere vacuum. Okay, two pieces. He is attaching the two pieces of the sphere, and he is vacuum it. And now he is pulling the both the sides of the sphere with each side with 8 horses. He is not able to pull them apart. So from this we can understand the strength of the atmospheric pressure. Okay, so the atmospheric pressure at the sea level, it is around 1000 kilopascal. Sorry, 100 kilopascal. The SI unit of measuring the pressure is pascal. Okay, that's it. And we are having now some real life experiences for air pressure. Okay, The first one, they are talking about the sucker. The sucker will have a rubber bell-shaped structure in the one end, the other end it will be fixed with a stick. So when we are pumping it, we can evacuate the air inside the bell-shaped structure when it is fixed to the surface. So when we are trying to vacuum the bell-shaped structure, it will stick to that surface. We cannot remove it that much easily. So when we have to remove it, we have to overcome the pressure inside with the atmospheric pressure, so that we can remove the or take off that sucker from that surface. Actually, this sucker is not completely vacuumed. It is having some air inside. That is why we will be able to remove by our hands itself. Otherwise, it is not possible, because we already saw the experiment with 8 horses. Okay. And the next example, a nut is thrown towards the sky and it is falling very fastly, all because of gravity. The second time it is tied with a thread and a handkerchief and it is thrown towards the sky. When it is coming down, okay, the air is making the handkerchief to spread, and the handkerchief is acting like a parachute, and it is slowing down the motion of the nut, and the nut is slowly reaching the ground. Okay, so now the atmospheric pressure is stopping the nut to fall down slowly, all because the contact of the handkerchief. Okay. And next one, they are talking about the straws. So if we take straws, we can use the straws for drinking water and cool drink. When we are emptying the air inside the straw, okay, we are creating a low pressure inside the straw, and the liquid is having the high pressure because it is in the atmospheric pressure. Okay, so fluid will always flow from high pressure to low pressure. So fluid starts flowing from the container to the straw. That makes us easy to drink. The same principle is followed in the last example, that is syringe. Okay, the syringe is fixed with a needle, and the needle is perished inside the medicine container where we can collect the medicine. When we are pulling the piston of the syringe, it is creating a vacuum inside and it is sucking the medicine inside, all because of the pressure difference between the atmosphere and the pressure inside the syringe. Okay, so we can collect the medicine the same way we can uh, insert the medicine inside the body of a uh, object, maybe a man or a animal. Okay, so from this we can understand that atmospheric pressure is also exerting pressure. Okay, by this we are finishing our class. First chapter is over. Thank you, class. If you have